Hello, good morning, good afternoon, good evening. Mark, I see you have an update on work towards Whimsy submission mid-June. How long will it take for you to go through it? I can't hear you.
The
Okay.
deadline, I think, is a few weeks ahead of the meeting, which is the week of July 19th. We're hoping to finish the work inside the Trustworthy Workload Identity SIG by mid-June and submit it, like polish it within the next week. Before the end of June, we should be submitting it.
Okay, cool. And it's a requirement document, isn't it?
Well, we're going to submit the requirements as we have defined them. And also, we will be talking in that draft about the differences between what we need for the workload identity to be trustworthy and what Whimsy offers. The two main points of difference would be that we need to integrate the attestation workflow into credential issuance. And the second one is that we need to include provenance into the workload, which is the provenance sounds more complex than it is. I mean, ultimately, it's just like a unique identifier that a credential contains, like a JTI tag or a unique, like a seed ID and SPIFFE parlance is the breadcrumb. And through the breadcrumb, you should be able to independently verify provenance by out-of-band means. But we should specify all that and explain it to them and see what they say.
Cool.
And then there is a question. So Whimsy defines this workload identity token, and I need to understand something about that. So specifically, I need to understand how is it actually bound to the message, because the workload identity token is basically seems like a like signature over JWT with the private key, but it's not bound to the content of a request. So if you steal that, you may still use it with other requests. It seems like, and I guess to my naive reading anyway, I need to understand this
Right.
before I speak more broadly, but yeah.
Cool, thanks. I think we are 5 minutes in, so we can start. Mark, do you want to do some presentation of the work that you're doing there?
Well, so the I suppose I can show something. I don't have a whole lot yet, but let me put it this way. I can put
Hey, Mark, can I ask a quick question?
oh, hi, Greg. Hi. Yeah.
Yeah. I just happened to glance at the Whimsy architecture spec this morning, and I found I, I I quickly scanned through it and I got to the diagram I saw a few months ago that made me feel a bit calmer. And I saw the diagram that basically included a call out, to as part of I think getting the credential where there's some attestation involved. And so I thought, okay, so they're still thinking about attested identities for the workload. So I didn't
Correct.
panic and just moved on. But it sounds like you think there's I guess uh, I have not read the most recent, Whimsy docs in a few months. So
Yeah.
what is the overall concern in terms of how this works with remotely attested kind of environments?
Well, so uh, perhaps let me show you what we've got so far, and let's see if that
Hmm.
begins to answer your
Okay.
question. Also, I am like 15-minute drive from Redmond campus, Microsoft. So, we can meet for a whiteboard session any day, talk it through.
Hmm.
Uh,
Okay.
but okay, let me show what I got. It's not as I said, it's not much. We just have um, a very skeleton document, and we start by saying these are the platform capabilities that we expect. So one is be able to generate your own keys, so secure random number generation. And again, this is for people unfamiliar with confidential computing. So it will probably can be obvious to us. Ability to test the workload through the quote, and ability to seal data to the platform. This one is an optional and I'll explain for short-lived workloads. We would like to see that. And then we talk about uh, the role of verifier and identity provider in workload credential issuance. So what we're defining is that there are three stages, at most three, and like some of them can be combined. One is credential provisioning. This is just a mechanism by which a credential is first created and made available to the workload. And we can talk, like I'll show you through the diagrams later what that means. And then there's credential acquisition.
You froze, Mark.
How about now? My internet
Yeah.
is not always very stable. Yeah. And then finally, credential usage. And this is what we all understand. Once you already have credential, you go ahead and use it to authenticate, authorize, etc. And so here I make a statement saying if a workload creates its own key and gets it certified, then provisioning and acquisition is one step. But in some cases, you need to pre-provision a credential before it's acquired. Uh, yes, Osama.
Yeah, Mark, so quick question. So what is credential to you? Is it the private part or the public part?
So that is defined in our working document. Let me bring it over so I can show you. So this
But
presumes
maybe you
knowledge
can
of.
just say, but maybe you can just say whether it's private or public. So
Um,
Need
where
to
is
keep
that? I'm
choosing.
trying to find. Hold on. Let me try. No, I believe it should be in that regard. No, the point is we have defined. Like, I'm trying to figure out where is that file written down. Maybe it's already got moved. Apologize. But we have defined these terms and we've discussed them. So then this is why I don't want to rehash what's already been said. Um, let me get back to it. But the credential is a it's really defined the way Whimsy defines it with a caveat. So you can look at that definition.
yes,
But
but can you maybe just say whether it's private or public?
so a X509 certificate is not a credential without its private key because you can't really, it's just the public portion is not like yeah, unless you can use it to authenticate, it's not a credential.
No,
I viewed it as an authentication credential. If you look at the Whimsy architecture document, they're borrowing a lot from OAuth, and OAuth is OAuth is is kind of like the backbone for a lot of IDP architectures, identity provider architectures. So usually a credential is the actual public-private key pair that's assigned to an entity, a human, etc. In this case, a workload. So the 509 certificate would, in that case, would be an endorsement of the credential, but it wouldn't necessarily be the credential itself. So I think you got, I think the definition, Mark, you provided is fine, but I think if you can refer back to OAuth, that kind of completes the loop.
Okay, well,
So Giri, does that mean that it is the credential that's being used here is the private public key pair? Did I get you right?
Yeah. So the
Okay.
so
it's
that constitutes the overall credential. Obviously, the private key should not be exported from a trusted environment if you want to keep security guarantees. But
it's not just the public-private key, because a public key pair does not carry any claims,
well,
right?
that's yeah, but I mean
Oh, maybe it's
that
in
would
the
be
charter. Hold on. Maybe it's
yeah.
in the charter, because we were very careful in defining this. And I also cannot rat hole on this right now, because I'm not going to get through everything I need to cover. So this is why I will refer you to this document that you can read.
So just to clarify, the reason I'm asking this is really important to understand what you are saying, because we have been dealing with this issue, the provisioning issue that you are talking about. I think I presented it at least a couple of times in the SIG already, and there is really an issue of how do you provision that key into that trusted execution environment. So it's
I
and we
will,
have reached a dead end to
Osama,
that.
if you
So
let me
I'm
just
just wondering.
continue, I'm going to go through
Yeah,
this and I will explain
sure.
it. And if you want a definition, I just put a link in the chat that you can read how we're defining it. And I can't like keep rehashing it right now. So, let's see, where was I just a second ago? All right, so yeah, so it made it into our charter. All of this is defined. Please take a look. All right, going back. And again, this is a very early draft. I will also put a link in the chat, of course, so you can request access, which I'm happy to grant, and you can start making suggestions, etc. So there we go. All right, so there's provision, acquisition, and usage. And so there is a mechanism defined here that specifically is around how would you get a certificate from a credential authority. So we use the mermaid thing, and then it's rendered like this. So by the way, there is, and then let me pull up a link to a more formal definition, because there is this another interesting link. There is a draft right now called CSR Attestation that I think this group also needs to be familiar with. So I'm going to put a link in here. Please take a look. It's an ATF draft. Greg.
Oh, quick question, maybe help illuminate the credential thing, because I do think it's important that folks are on the same page. Is there a so when I think of credential, I think of like Azure Active Directory, that's what I'm most familiar with. And a single service principal can have multiple credentials that basically prove that you are a party with access to that service principal. So are you using it kind of similarly here? What's the like relationship between a workload identity and a credential? Is it one-to-one or one-to-many?
All in here, all in here. So workload identity is defined as the WIMSI defines a combination of identifier and identity credentials. Okay, so then workload credential is so okay. To answer your question in less formal terms, I believe that a workload instance may have multiple credentials. So for instance, you may present one credential for purposes of somebody authenticating to you over MTLS. But then if you go talk to another workload that is, within your kind of larger trust boundary, so perhaps payroll application may expose a web interface and has a workload credential that it presents, so it's, people can talk to it over web, and then it talks something to talk to payroll database, and maybe a very different credential.
So a workload credentials purpose is to prove that you are the party that that you are the workload identity. You are the party you are the party that is effectively the workload identity. And you
Right. And you may
can
have
prove it
multiple, right? Because
you may
a
prove it
workload
multiple different
instance,
ways.
yeah, a workload instance could be using one credential talk to the payroll store,
Okay.
right? And then maybe another one to write logs.
Yeah.
And maybe using another one to go authenticate to some, outbound servers, like a SaaS workload outside. So yeah, you may issue multiple credentials to a workload instance that are, different.
But what's is a workload instance have one workload identity? So I just want to be careful, right? Because you may have one workload operating as multiple workload identities. So I'm very specifically asking about workload
But it can have
identity.
multiple identities with a
Yeah.
credential for each. So the workload identity to
Okay.
credential, I hesitate to say it's one-to-one because you may have, different ones for different time spans, for instance.
All right. So maybe I'd be it helps me kind of be hopefully be on the same page to just at least kind of say, well, the workload credentials purpose is to prove, correct me if I'm wrong, but to prove that the party behind it has privileges to act as this workload identity. It's a way to bootstrap or prove that
I am
the
happy to provide this clarification. So this is an empty file in our GitHub. So we can like file an issue. Like maybe we should have an ERD, right? That like outlines and have a more extensive discussion to make sure that these questions are answered to everyone's satisfaction. But just one caveat on this. So in the TWISIG, we must achieve one thing above all, is that we remain compatible with major players in that space. So, and if the compatibility is impossible, we need to convince them to change. So let me give you examples. Generally, our definitions cannot differ too much from what Whimsy does if we're going to be compatible with Whimsy, right? Otherwise, the collaboration with them becomes impossible. But Whimsy, on the other hand, does not have a concept of credential provenance. So that's the conversation with Whimsy is how is verifier integrated into Whimsy, and how can we convince Whimsy that we can carry provenance of a credential in the credential itself, right? So, but we need to maintain as much compatibility as possible. And if we change our definition of, say, workload credentials so much that Whimsy doesn't recognize it, it actually damages our effort, doesn't help it. So, but I'm happy to try and work out an ERD between these concepts, so we can more clearly explain how the relationships between these terms work if it's not clear from this write-up.
I think the feedback from me at least is it's not totally clear, right? There's questions remain,
Okay,
to
tell
be
you what.
answered, and it perhaps is that there are answers in other docs and so on.
Yeah.
So,
My best suggestion would be to file issues in GitHub on this document and let us answer it to the best of our ability.
Sounds good. Thanks.
Right? So say what's not clear, and then we're going to make sure that we clear it up. So that's, of course, it is important. Yeah, Osama.
No, Mark, we just
Yeah.
want clarifying. And by this document, you mean the TWI charter, MD?
Right. So if the definitions are not clear and the definitions are in this document, then we need to clear up this document.
Okay.
Right.
Let me note this.
Yeah.
I mean, I'm repeating myself, but this is what I already said in the meeting of in the IETF meeting, right? So I already gave you the feedback that the definitions are not correct, and I wonder if just by creating a GitHub issue will be the resolution of the problem. I don't see what exactly is your difference between the identifier. I completely understand you that you are trying to be compatible with Whimsy, trying to make some definitions which are understandable for them. But at least for me, from confidential computing perspective, I don't see what is exactly the difference between the workload identifier workload identity and workload credential. Is it the private public part that the TE generated, or is it the private public part which is
Okay.
which is given to it from the outside? So which
Okay.
exactly
So
is it
let me try and
that
explain again. Workload identifier, just let's put it in concrete terms, and perhaps we can generalize from there. Workload identifier would be like an SVID, right? It's a URI. And it contains some information about, like, this is payroll application, but maybe has additional claims, as in it's a payroll application running in Germany. That would be workload identifier. So no public private key, it's just a name. Like my name is Mark, that's my identifier. Now, workload identity is a combination, as it says here, the trust domain, workload identifier, and identity credentials. This is defined by Whimsy. If Whimsy definition is not up to par, you would need to get them to change, because we need to be compatible with them primarily. And workload credential is now a thing that is an identity document that you are not going to be able to impersonate without some private information.
I mean, we already discussed it in the Whimsy meeting, because their concern is not about confidential computing. That's our concern, right? So they would not change their definitions from our perspective. We have to justify what's required or what's needed. So
Except
in
for
that
Whimsy
context,
already has this thing called a WIT, which contains binding, and it has it's compatible with SPIFFY, SVIDs that are X509 certificates. So again, if you don't like that definition, Whimsy is what needs to change, and then we'll follow suit.
so I think I have failed to clarify my concern. So what I'm saying is that they don't need to change their definition. We have to show that what's missing in there. And your definitions don't have to follow that. I mean, you have to clarify us what does this really mean from confidential computing perspective, rather than following them that that's their definition, and I'm trying to be as close as possible to them.
So I'm trying to
So
answer your question. I do not know if you're actually listening. Whimsy definitions are fine from the confidential computing perspective, for the most part, because already WIT contains binding between the workload instance and the workload credential. And that's what confidential computing requires. And what Whimsy misses provenance, but that's very simple to add because there are unique identifiers on credentials. I mean, if there are particular things that you believe that confidential computing needs out of Whimsy, again, you can write them down, and we're going to assess them and see if that requires a Whimsy definition change. But I haven't seen anything that makes them like fundamentally incompatible with confidential computing. So let me try and go back to this. So I already put a link to CSR. This is kind of a simplified version of the CSR attestation, but the idea is you can, in the credential acquisition phase, you generate a key. So notice there's no credential provisioning here because the workload generates its own key and gets its own unique to workload instance credential. So the acquisition phase is you generate a key, create a quote, create a CSR with that quote, and request a certificate with the CSR. Again, the CSR attestation pretty much talks about that. And then your certificate authority will talk to the verifier and get attestation results from the CSR. And then from there, it's going to be able to get the certificate back to you. Again, if this is incorrect, I'm happy to change that. Here's another model where you get your certificate from an HSM. In this case, there is a provisioning phase. So let me explain. The workload owner, which is not the workload instance, but this is somebody who wants
So
to
one
deploy a
quick
workload.
question, Mark, about the last diagram. So about the attested CSR.
Mhm.
So does the certificate, what exactly does the certificate contain? Does it contain the attestation result inside, or does it contain the evidence inside or not?
So the certificate will
So
contain.
the last step that is there, so this certificate issued by the certificate authority, does it contain attestation results or evidence inside or not?
No, No, will not. It will
Okay,
contain
it's a
certain
normal
attributes.
X509 certificate as if that will be issued without any
Right. It has a
any
subject
attestation.
name. It can have issuance policy OIDs. If you want to say, you know, the requester satisfied certain policies around issuance of a certificate. But yeah, this is ultimately very much like an X509 SVID. So if you
So
want to
how
see what
would a
that looks
third
like.
party, how would a third party know that this certificate actually is verified with evidence versus without
Policy
evidence?
ID. There's a policy ID in the cert that says the verification method for issuance has been through
Yeah,
a verification.
X509 OID would be used, correct.
Okay, so
Also,
it's
there is
not
going to be a unique identifier in there that you could then go check with the issuer to see what, you know, how the provenance came about. We should discuss, we should have a discussion of these methods. That doesn't exist yet, but we don't have that yet. But yeah, it's not going to have all the evidence and all the proofs now. It's in
right,
fact
but
also
it's not exactly the same as a normal certificate. It has some additional fields.
no. No, if you
Mm.
look at X509 X509 SVID, that's pretty much what it has. And again, the moment you start deviating too much from what's out there as far as deployed standards, you kill your ability to deploy, and then it doesn't matter how good the work you're doing is, because
But
it's
policy OIDs are in industry standards, right? So
yeah. So that would
kind
be
of
fine.
signal. Yeah, exactly.
Yeah, absolutely. And again, I need to add a little bit of a clarification to this. As I said, this is a very, very early draft. So yes, putting an X509 OID saying this was a, you know, was satisfied that this is a confidential computing workload, for instance, might be a fine attribute to add to the certificate. But need to stay within, mostly within the accepted guidelines. So for an HSM, this is actually very close to what's going on today. So there is a provisioning phase. The workload owner, before the workload even starts, basically gets a public key pair and an HSM. HSM generates the key pair, gets the public key back. Then you create a CSR, get a CSR with a private key, and then you go to your certificate authority and have it issue a certificate. And then you put a key access policy on the HSM, basically saying somebody needs to come in with the following reference values from the verifier to get the key. And then now your credential acquisition phase. So critically here, every workload instance shares the same credential, right? Same private key, same certificate. I don't personally love it, but that's, you know, you need to support this. And you generate a quote using your cert, you get back attestation results. With the attestation results, you go to the HSM, and HSM will release the private key to you, the workload instance. So the workload owner never learns the private key. The workload needs to run with the policy that the workload owner specifies with the quote and be able to get the key. So here you get your credential acquisition, which is separate from credential provisioning. Let's see what else we have in here. Another one is, remember we talked about short-lived versus long-lived workloads. So here we have a credential provisioning phase where the workload somehow gets a credential using the mechanisms I described before. But then whatever private key it has, it concealed to the platform. So that's provisioning. And then the acquisition phase is when the workload runs in, and just gets the credential back that's unsealed, make sure it's still valid, and then uses it. And again, more discussion is needed around what does this verified credential even mean. It has to do with that workload needs to ensure that it's running in a secure configuration, things like that, which again, I'm happy to discuss. So again, this is early days, but these are the kinds of things that we are hoping to show. And the key motive here is we're trying to integrate verifier. So the what the this sort of the bread and butter of this SIG with the work that the attestation SIG is doing. So basically integrating verifier attestation results of that business with certificate authorities and HSMs and control planes and all of that business. Osama, you have your hand up again.
Yeah, so two questions. The first one about the data residency. So, for instance, in Germany, we have regulations that the health data should not leave the Germany part, right? So
Correct.
how is that ensured from regulation perspective?
Okay, haven't written that part yet, but this is how we believe this needs to happen. So if you remember, last time we talked about combining two attestations, a workload attestation, where you get trustworthy claims about your workload that are effectively vouched for by Intel. So if, or Intel or AMD, whatever, if your silicon vendor is not trusted, well, then you really don't have confidential computing anyway. So, but that says nothing about the location of the server where the chip runs, because the chip cannot speak for its own without like integrating, I don't know, like a GPS receiver into the CPU. Can't really tell where it is. And the second attestation is the platform attestation, and that's effectively TPM based or VM based. And this is on, you don't trust Intel for this, you need to trust your CSP, so Microsoft or Google, right? Or you need to trust your own control plane in your data center, for instance. So, and then you take both claims. So you attest the TPM, perhaps using the virtual machine ID or the TPM ID, right? Using TCG style attestation of PCRs and whatnot. And then you take a workload instance attestation, and then you combine them into a complete identity of the workload that will contain claims about the workload instance and claims about the platform. And we already talked, I believe last week we mentioned how the source of trust for those two types of claims is different for the reasons I just specified. Like I don't trust CSP, Microsoft, to tell me that this is my payroll application. For that, I trust the Intel quoting mechanism. And I cannot trust the Intel quoting mechanism to tell me where the geographical location of that server is. And for that, I have to trust Microsoft or Google. Does that make sense?
Right. So basically the summary of that is that you have to trust the CSP in order to tell you the location, right?
Correct. And
okay, right.
we do. And we do.
Yeah.
This has been something that's come up a couple times in the last couple meetings, and I thought about it some more. And I think with the threat model for this information, like the source of truth is the CSP, and the threat would be somebody else interposing and changing the value from the CSP around like the region, the cloud region that a machine is in, for instance.
Yeah. And
right.
it would be interesting to see how real this threat is and what the mitigations might be. I would like to work with someone on this in this SIG to draw the swimlane diagram that shows how TPM style attestation and quoting style attestation can be combined. Like there is a nonce involved. There is, what are the threats are, to what extent are the threats mitigated? So for instance, how do I know that I'm not doing TPM attestation from one server and combining it with quoting attestation from physically a different server? Like, how do I know that they are the same? And that's, a question that a properly designed protocol should be able to answer. And I don't have that answer yet. So, this would be a great area for collaboration.
Cool.
Yeah,
Thank
that
you,
would
Mark.
be interesting. Well, so one more question about this. So there are, sorry, Thomas?
No.
Go ahead.
I thought you're right. You had two questions and only one was fired. So go ahead.
Okay. So About the location, I think we all agree that basically you trust the CSP. So kind of concluding the first part in all the discussions we had over the last meeting. So we agree that CSP is trusted for the location. So that's one thing that I want to emphasize. And second thing about the runtime measurements. So the flow that you showed for CSR, a tested CSR, it's doing a one-time attestation. It's issuing a certificate. I don't know what the validity period of that would be, but whatever that validity period is, so there could be a change in the runtime measurements. How do you foresee that would be taken care of? For instance, your application profile is changing, and that's being measured by the
Okay.
TPM.
Let me try and give you my my answer. I do not know if you like it, but maybe there is a better answer. So let's say I'm testing a virtual machine. And the problem, as I see it, is I'm testing a virtual machine, and then after I tested it and got a credential, the virtual machine went and loaded a bunch of other stuff. Or maybe administrator has logged in and changed some policies on the virtual machine, including code signing policies. And then it went and did a bunch of stuff. So, it has morphed, and it's no longer the beast that has attested. So that's a problem with a large extensible TCB, which is what confidential computing is ultimately doing, is attesting a large TCB unless you're doing enclaves. And the way I see that answering is that when the virtual machine launches and the things that we measure for purposes of this initial attestation is a set of policies that that virtual machine is going to enforce. And those policies might be code signing policies. So I will only load code that's signed by the following keys, and unless it's signed by these keys, I'm just simply not going to load it. Maybe another policy says interactive or even network logon by administrator is prohibited on this virtual machine. There is not going to be an administrative backdoor through which this workload can change. And then you effectively seek how to, if you're not outright prevent extensibility of the VM, severely limited to only the mechanisms that you can attest and then later trust. And then the consequence of such a thing would be that even if it did morph, it morphed within the boundaries that you promised during your initial attestation. And if you didn't specify any boundaries, well, then your attestation frankly isn't worth much for something as large as a VM. Does that make sense?
Somewhat. So maybe to summarize my understanding, what you are saying is there would be a policy that will be enforced by somebody, I don't know who, but that would be something like the network login by the
Well,
admin
the
is
VM itself,
prohibited.
ultimately, right? It needs to defend itself.
Right, but how would that VM make sure that there is no network login by the administrator?
Because there
Perhaps
is a
that's the point
policy. There is a policy that, and whatever that policy is, you need to be able to measure it for purposes of attestation and then later enforce it. So
I see a circular loop here. So the VM is being measured and the VM has a policy that it is defending itself. So
correct.
I see a cyclic loop, but
well, so one mechanism might be that there is a private key inside the VM and there is some sort of antivirus or policy agent running inside the VM that you also attest. And then this thing monitors the VM. And then if it detects that administrative login has happened or any other out of policy event has happened, it wipes the private key from memory. Right. So any attempt to attack it would effectively, fail closed. And so, I mean, we can discuss and document all the mechanisms possible. But my point is, if you are attesting a virtual machine, you have to ensure that the extensibility is either prevented outright by a set of mechanisms or strictly controlled by a related set of mechanisms. And I don't see any third option, but maybe somebody does.
Okay, right. Thank you. So about the point that you mentioned about collaboration, I would be interested in the protocols since we have been looking into the attested TLS protocols. So I would be interested in
Yeah,
looking
so yeah,
into
absolutely.
different forms.
So the goals for that particular collaboration, and I like to keep things narrowly scoped if possible, so that we can pick up something that we can wrap our minds around, and then get it done, and not try to do too much at once. But ultimately, the idea is there has to be a protocol that combines. So let's limit it to a virtual machine with a virtual TPM or a physical TPM. Right, and a VM that itself runs in a trust execution environment like TDX or whatever AMD, and then a protocol that goes to the verifier. Maybe there's more than one verifier. I don't know. Gets a nonce and returns a TPM quote and a TC and a CPU based quote. Right, and then how the two get to be combined, and and the threat model around it. So what can go wrong, and how can the two attestations be bound together so you can't attest, the platform other than the one in which you're running, or maybe it's not possible, and then we need to become clean and say, that's going to be best.
Good, thank you.
Cool. Oh, Yogesh.
I mean, no, it's
No
okay. I
worries.
just thought Mark said it is not possible. I don't think that's the true statement. There are multiple ways of doing it. It depends on an individual implementation. I think you can have some kind of outer signature which bounds the two tokens together, or there could be some crypto linking between the two claims within the tokens. And so just wanted to make a
Well,
quick comment on that.
we need to say, if we
Yeah.
can make it work in a subset of cases, then we should document
Yeah.
those cases, right? And we should
Sure.
understand what the limitations are. So, for instance, maybe there is something about the virtual TPM that can be included in the CPU style attestation, and then we really know it's that VPM, maybe it's that endorsement key from that
Exactly.
VTPM, and no other. But right, so we need to
Correct.
figure out what that is,
Sure.
and then as we invent new mechanisms, we can add to the menu of choices. But I would like to get something, one thing, something small working, and then see how it can be expanded, rather than try to do something that works for all. Used to call it at Microsoft, all singing, all dancing. Let's not start that.
Sure. Thomas,
Okay.
over to you.
Yeah, just saying. Okay, we can conclude this slot and spend the next 15 minutes, I think, or slightly less, to discuss the items on our backlog. So did you? Okay, let me share the thing. So issues. Share. You see anything coming from my screen? And what is that? Is it an issue tracker with the? Okay, perfect. So this is our backlog at the moment. We have done a pass, or maybe more than one pass on it, to try and categorize the issues we have into macro areas as much as possible. There are things that are not yet labeled, I see, but since we are talking about these binding things and composite attest and stuff, we have a cluster of 3 issues that are related to the composite attest topic raised by Greg and Yogesh. I see Yogesh has the longest history here, a couple of years ago, a year and a half ago. So I think this is a very nice piece of activity that we could work on. There
Totally.
are multiple dimensions to this problem. This is, the idea of modeling composite attesters topologies in either multi-rot or layered situations, or a combination of the two, in fact. And as far as I can see, reading through the comments in the issues, the idea is that we want to look at that from the point of view of certainly the attester that is creating this composite evidence. And, the problem here is how you want to how you express the topology. That is the relationships among the attestation environments, target environments, in a non-temperable manner, right? In a way that can be subverted. But it's also from the point of view of the verifier that is creating the composite attestation results. So in that sense, you need to be able to express the accepted topology in the attestation result from the perspective of the verifier. But it's also it's not just dual. There are three actors here that are important, and the third one is in fact the endorser, that is the supply chain entity. It can be an integrator, can be something else, but is someone in the supply chain of the device that can create the composite endorsement. So it is the way to tell a verifier what the attested topology look like, right? So that the verifier can make sure that all the pieces that are expected are in place. So I think there are these three aspects to consider: so the evidence formats, the attestation results formats, and the endorsements formats. And what we could do is do some background work in terms of analyzing the existing deployments. So what, for example, Azure does with the platform TE and VTPMs, what ARM CCA does, what DICE does, what Intel TDX plus NVIDIA does, right? So how these things that already exist are actually and document them. We can also look at what these emerging standards are in this area. So, for example, EAT submods, CMW collections, X409 certificates in the case of DICE, etc. And we can look at specifically for the evidence formats at the binding models, right? So nonce-based, HashLock, key delegation, whatever, right? And document all this stuff. So Yogesh in 22 suggests we create a document. We have a working document with all this stuff. So I was really tempted to go ahead and create a table of contents and then have a collaborative editing on the document where everyone who has some knowledge in the space in one of the identified subspaces can contribute their thing, and then we accumulate knowledge this way. In parallel, we could have sessions where specific aspects are presented in a more comprehensive way, and that there's some discussion and whatnot. But this needs volunteers for preparing presentation. We can certainly do cover some of the aspects, especially regarding the standardization. I can contribute a few slide decks and binding as well. But we really need to be all involved in, or not all, but all who has knowledge in this space needs to be collaborating material to this. Yogesh, I saw you have.
Yeah, I don't know. It automatically, I know. So fully agree with what you say, Thomas. And I think my idea was originally to kind of work in this community, a document. And so would be happy to cooperate and coordinate with you on this.
Okay.
Second thing is we are already discussing the other side of this. What you suggested is the composite attester device description, how the topology is, how the evidence format would look like, and all those things. So that, and the other side is how does it gets verified. So we have already started that work in the RATS working group about the composite verifier or some multi-verifier stuff, which is quite relevant to the other side of discussion. So I just wanted to share that here in the chat.
Yeah, that necessary contributes to the stream.
Correct.
Also.
Yeah, exactly. Yes. That's all from my side. Thanks, Thomas. Yeah.
Thank you. Jiri?
Yeah, I just wanted to make sure I understood you, Thomas, correctly on this. Would this work be focused more on the points of interoperability, like, as a kind of made up example, the CMW format for a composite attestation with multiple roots of trust? Or would this work be actually focused on attesting to the composite attester topology, which I kind of view as different, right? So that, I mean, one is the bits over the wire, and that doesn't necessarily, you may be able to imply something on topology from that, but it's not necessarily, but it doesn't necessarily provide an accurate representation of topology. Um, I'll give an example, right? Like in the early days of EAT editing, when we were editing EAT, I got a weird request, or I shouldn't call it a weird request. I got a request to put in a TPM claim into an EAT attestation, which was kind of unusual to me because I said, well, the TPM itself is self-attestable. Why does this need to happen? But I mean, there could be use cases for that. So you could have a composite attester which has two roots of trust, maybe something like an ARM RSE core forming the EAT attestation, and another is a TPM attestation, and they're both sent in a CMW grouping. Or you could do what the suggestion said, which was the TPM attestation is provided as a claim within the or a submodule within the EAT attestation. So you could the topology could be the topology, in my opinion, is essentially the same in both cases, but the bits over the wire are very different. So that's
And I
yeah.
agree, but there's a way to distinguish the two things, isn't it? Because the EAT that contains the TPM as a claim will have its own profile, which pops up in the media type of that CWT or JWT that wraps the claim set. And the same can be said about the CMW if you're using CMW to wrap the two things as separate typed objects. So there are ways, even on the wire, depending on where you're looking at, right? Which part of the wire you're looking at, which layer, that can drive your topology understanding. But I get your point. There are multiple things, multiple ways to do this kind of aggregation. I think we should document all these things and then maybe suggest what is a best practice, right? So something like that could be a good outcome of this whole exercise, I would say. Usama?
Yeah, I just want to follow up on what Jogesh mentioned. I already provided some feedback. I've put it in the chat. I am not fully convinced of what really the motivation of the work is. Why do you need to have two separate?
Sorry, which work?
So basically the multi-verifiers work that Yogesh
Okay.
mentioned. So just to clarify my concern, so we have done the security analysis of ARM CCA where we have two attesting environments, and RATS is more fuzzy than any other fuzzy logic that I have considered. So I would consider that as a composite attester because there are two separate attesting environments, and together they are sending over two different evidences, which are platform evidence and then your workload evidence or whatever, REN evidence, whatever that you call it. So the thing is, now you have two evidences, and that would, for me, compose a composite device or composite attester. And if you have two separate verifiers, or if you have one integrated verifier, that wouldn't make any difference in security from security perspective. That is, I am just verifying as, let's say, the design that was proposed as a not the design, I mean the use case that was presented in RATS considered that Intel Trust Authority and NVIDIA basically are doing separate verification that's no different from Antitrust Authority simply fetching out the reference values and the endorsements from NVIDIA in order to do the verification. I don't really see what's the benefit of this from security perspective, number one. And I refer to the paper in my email. And number two, from privacy perspective, if we see, that's again indifferent because NVIDIA is not seeing what was intended for Intel. That's fine. And that's also the case if Intel is just fetching the values, right? And the other way around, Intel is actually seeing the evidence from what was intended for NVIDIA. So I don't see any benefit of separating the two things. So I really
Right.
would like to see a better motivation for this work.
Right. Kusama, can I interrupt you here? Because this is only tangential
Exactly.
I was
Yeah.
talking about. So you can deal this with Yogesh and
Yeah, we will discuss that,
Right.
Osama, on a separate forum. Yeah, that's
Thanks
what I
very
was
much.
going to
We
say.
have only 4 minutes, so Greg, please.
Yeah, I just to me for the space I work in, this is very any activity in this space, whether it's reviewing what's out there, reviewing emerging standards, is all excellent stuff. From my perspective, we've got two simultaneous trains going on. We have the reality of what's like going on, at least in Azure, right? We already have a composite scenario. We have platform based confidential VMs, be it TDX or be it SetSMP, and then we have BTPM, capabilities on top of that, and they are actually tethered together in attestation evidence and token from MEA. And it's just been done bespoke ad hoc, historically by some folks in Microsoft, how they've done that. And this is a growing area, right? We've got lots of devices appearing, we have GPUs and more things coming along over time. So, and there's also the standards work that seems to be, happening, and we have the CMW and et cetera. So the from my perspective, the more educated people like me who are in the trenches, having to build this stuff out as we speak, and getting intimately familiar with where the in parallel standards work is going will just align them closer from the start versus, once you put something in production, it's very difficult to change. You have to, it's measured in years. And so that's where, from my perspective, the next year or so is kind of a critical time where I think there'll be a good amount of activity in this space, in both the standards and the implementation track. So the closer we can mesh those two, the better the next 5 years are going to be. And it could be, quite frankly, any sort of discussions in this space from my perspective. Getting the standards people more familiar with what the heck the workarounds folks have done in the last 5 years, and getting the people implementing more aware of what the standards folks are folks who are more frequently involved in the standards discussions are planning for.
Yeah.
Fully agree.
Big giant +1 here from the Google side as well.
Yeah, right. So from my perspective, we can start today, right? Well, no, it's night on my side of the world, but tomorrow morning I can start, putting together this talk and then distribute this, and each of us can go ahead and do provide the piece of knowledge that they care about and they know about to the collective thing.
I don't know if it would be helpful or more of a distraction and a rat hole, but I could look for somebody in Microsoft to kind of talk about how we've currently bound the platform level evidence with the TPM level evidence and model that in both the evidence and the
Absolutely.
attestation results side. But it's very, it's very bespoke. It's very specific, and it's
I think we can learn from everything, right? So, I think documenting existing deployments is one of the fundamental bits here, not just documenting the standards and what the theory is and what because we can match the standard effort and the existing deployments and see whether we can carve out some best practices that for the next 5 years, as you say. That's really the goal here. So
Mhm.
I don't know whether you could summon that person and to have to
Yeah,
present.
I'll put on my, I'll see if I'll see if I can find somebody.
Mhm.
I hope that I can. I am a little hesitant. I would not be the best representative for that. So I hesitate to volunteer myself, but I'll work on, figuring out somebody, if I can motivate somebody to come and present.
Thanks very much. And by the way, we are at the top of the hour, unfortunately. But if you are okay with that, then I take the action to create a Google Docs or something like that and go ahead with this and then notify the list or the Slack channel that this is ready for contribution.
Please do.
Sorry, Hank. What
Please
was that?
do.
All right. Okay. We need a chair for next time. Keith, Jim, Greg, I don't know who's next, but
Yeah, I don't think it was me. I was the one before this.
Yeah, I think it's probably me. I'm just checking my calendar real quick to make sure that I won't have to hop,
okay.
bail out of that. I think that would work for me. I can be the chair next time.
Okay. Thanks, Keith. There's already someone on the agenda, if you noticed. Someone from Thales who wants to
Excellent.
present.
Makes it easy.
Cool. Okay. Cheers. Bye-bye.
Thanks, everybody.
Thank you. Bye.